rational exponents, what we're looking at, rational we know means fraction, so we're talking about having an exponent that's a fraction. We've done this before, this easy schmeezy review for us. We know the numerator is our power, and we know the denominator is our root. So you can remember back to Algebra 2 when we said 7 million times, power over root, power over root, power over root. That's the stuff that we're dealing with in this. Okay, it's the same, nothing's changed on that. The numerator in a fraction, exponent is your power, denominator is your root. So we can simplify some of these. We're just going to work our way up through the different types of problems. We can simplify some of these real simple. Everybody got what we needed there? Power over root. Everybody got that? Real good. If I had 32 to the 1/5 power, so to evaluate that, okay, your calculator can handle that. So that is one option. We learn how to do stuff on the calculator and without. With our calculator, we would type 32, our rooftop button, and then we would enter our exponent as a fraction up there, and it could do that for you. Other way to do it is to rewrite it using power over root. So I've got 32 to the first power, and you don't have to put that first power because that means just 32. And then we take the 5th root of it. Now when we made our list yesterday, we didn't make a list of perfect fifths. We did a square root, a perfect square, a perfect cube, and a perfect 4. We didn't go to fifths. But we know if we're going to multiply something by itself 5 times and only get 32, it's got to be a pretty small number. So you got a pretty good idea that 2 would be a good place to check. So I could run through my 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it is 2 on that. Now anytime when you got a fraction exponent and the numerator is 1, that just means you're doing the root of the denominator. So if you had a fraction exponent that was 1/2, you'd be doing a square root. If you had a fraction exponent that was 1/3, you'd be doing a cube root, right? Ready? Because power is 1, it doesn't change anything. Okay? What if we had, now that I said that, what if I had 64 to the 1/2 power? Don't tell me what the answer is, tell me what that's the same as. What's another mathematical way to describe 64 to the 1/2 power? Not divided by 2, but you're on the right road. What'd y'all say? Okay, square root of 64. Right? Because it's power over root. So you would get 8. Okay, now you could, I don't want you to get, you could just type that into the calculator. Okay, that works also. So that's all good, all good. Now, when we throw negatives in this, when we've got even roots, we know you can't have a negative underneath there when it's an even root because that's an I. But it all depends on how the question is written. I want you to look at this. This is 2 different questions. Negative 81 to the 1/4 and negative 81 to the 1/4. Okay, the way those are written, one of those has got a real answer and one of them does not. Okay, this one over here on the left, the way this is written with the negative out in front, that means we're going to work the whole rest of the problem. We're going to do 81 to the 1/4 to get an answer and then make it negative. That's what the negative stuck out in front is, and that's the way your calculators work also. So if I did 81 to the 1/4 power, that just means the 4th root of 81. We made a list of perfect 4s yesterday. That's on your notes from yesterday. What is the 4th root of 81? 3. Good, Rachel. And then we got that negative, so we stick a negative out there. Now over here, the way this one's written, that means do that whole thing to the 1/4 power. So that means do the 4th root of negative 81, which we talked yesterday. And remember, we know in real numbers that can't happen. We know imaginary numbers from Algebra 2, and we can make that 3i. But for now, we're looking for real numbers. So we would just say not real. Okay. Alright, now all those so far have had a power of 1. The numerator was a 1, so let's change that up some. Let's look here at 25 to the 3/2 power. Okay, if you're typing it in your calculator, that's fine. Go ahead and do that. Power, I got 25 to the 3rd. Root is a square root. If I wanted to work it out this way, which would I do first? 25 to the third or the square root of 25? What's your thoughts on that?
Square root.
I would be with Zane on that. Wonder why. He said do the square root first.
Yeah, broken up by 6.
Right. If I was going to use a calculator, I would just go ahead and type the original problem in on my calculator. If I wanted to do 25 to the third, I have no idea what 25 times 25 times 25 is, so I'd have to use a calculator. If I'm going to do that, why not just use a calculator in the first place? So I'm going to be with Zane and go ahead and do the square root of 25 because I know that square root of 25 is 5. So now we're looking at 5 cubed, and that's something that if we don't know that in our head, it's in our notes. 5 cubed, 5 times 5 is 25 times 5 is 125. Okay? All right. So here I've got negative 64. Notice how that's written to the 2/3 power. That's a 2 up there that's got an extra little branch on it. Negative 64 to the 2/3 power. Alright, first off, is this even possible? Because we did one a second ago that had a negative in the parentheses and it wasn't possible. It wasn't real. Is this one real? Yeah, because, good, Chase, because we're doing an odd root. The root's 3. You can do an odd root of a negative. So this means I need to take the cube root, power over root, cube root of negative 64 squared. Now look right there, that negative's going to go away anyway. Because what do you get when you square a negative? Positive. Very good, Rachel. Now, some of you might know what negative 64 times negative 64 is. I do not. But I do know what the cube root of negative 64 is, and we wrote it in our notes yesterday. It's negative 4, isn't it? 4 times 4 is 16 times 4 is 64. What's negative 4 squared? 16. Shazam. Alright, now we got some negative rational exponents. This one says 81 to the negative 3/4 power. Thoughts on that? What are we doing? We got a negative power. I've already done it in here this year. What are we doing? We have a negative power. Very good, Grace. Reciprocal of it. 81 is the same as 81 over 1. So the reciprocal will be 1 over 81. And then our power becomes positive. So now we're doing the same thing that we just did. Power over root. It's just down there in our denominator. So that'll be 1 over 81 to the third. And I need the 4th root of that. 4th root of 81, that's in our notes from yesterday. 3 times 3 is 9, times 3 is 27, times 3 is 81. And then 3 to the third. Yep. Okay, what if the whole, I got what we need on that one? What if we've got a fraction? 64 over 25 to the negative 3/2. Now in the previous one it was just a whole number, it was 81. This one we've got a fraction. If you were listening, Grace told you how to cover this though. It's a negative exponent. What do we do with it?
I heard it say reciprocal.
Yep, so good job listening there. That'll be 25 over 64 to the 3/2 power. Now we have to do the 3/2 power to both of them, the top and the bottom. We made it a positive when we flipped it. So 25 to the 3/2 power, that's the square root of 25 cubed. 64 to the 3/2 power, that's the square root of 64 cubed. Square root of 25 is 5, and then we got to cube that. Square root of 64 is 8, and then we got to cube that. Find out the cube we've already used once today. I don't think on my cube list I went all the way to 8. I think I stopped at 7. Did I go to 8? Anybody got theirs handy? Oh, I did? Oh, you overachiever. 512?
Yeah.
That a kid. Way to be an overachiever. I like it.
It was kind of bugging.
Is what?
It was kind of bugging. You got 15 on my list.
Had to make them be. I got you. I got you. Use it, schmooze it. Alright, every now and then, don't see these very often, but every now and then you get to take the easy way out, something that maybe is not a perfect square or perfect whatever. It'll just say rewrite it. So if I saw 19 to the 1/2 power, the directions say write the exponential as a radical. Okay, this is deep here. This is an exponential because it's got an exponent on it. Whoa, hope you wore your waders. So if I want to rewrite that as a radical, it's got to have a radical in it. So that's all we're doing. We're not actually solving it and figuring out what the square root of 19 is. We're just rewriting it in radical form, knowing that those are the same. Okay, so we ought to all be able to do that. Don't need to practice a ton of those, do we? A ton, that's a new word I just made up. Alrighty, this one I've got, I'm going to do some power rule review here. I've got 3 to the 1/2 times 3 to the 1/3. Alright, so base is same, 3 and 3. What do you do with powers when it's multiply? You do add, good job. So that's 3 6 plus 2 6, which would be 5 6. So we would have 3 to the 5 6. That's a 5 and a 6. That's bad to read. 3 to the 5 6. Alright, let's see. That was multiplication, so how about a division? 7 to the 2/3 divided by 7 to the 4/3. So we got same base, 7 and 7. What do you do with exponents when it's division? You bet your boots you do. 2/3 minus 4/3, that's already got a common denominator. So 2 minus 4 is -2. Now, we got that negative exponent again, so we got to take the reciprocal. Good job. Alright, you got a couple more. We throw a bunch of the rules in there together. Let's check these dudes out. I got a to the 1/3 times b to the 2/3 over b all to the 6th. Alright, so what's up when we got that power of 6 out there?
It goes to everything.
We've got to give that. That means everything gets a 6. 6th power. So when I take it here, there's already a power there. So I'm looking at power to a power. What's your rule when it's power to a power? You add, subtract, multiply, divide. Multiply power to a power. Very good. So that's 6 times 1/3, which is 2. So same thing here. My b, that's power to a power. So I multiply 2/3 times 6 is 4. Don't forget down here, now there's not already a power on that b on the bottom, so that's an understood 1. So 6 times 1, make that a b to the 6th. Now, not done on this one. What do you see that you can still simplify there?
B's.
The b's, you got it. That's division with those b's. So that 4 minus 6 is -2. Since it's a -2, where do you think we're going to put it? Good job. On the bottom and make it positive. Yeah, all our smart cookies sometimes.
Hey,
Hey.
you're smart all the time.
Yeah, don't always do things wisely. Alright, let's have a fun one here. Everybody got what we need on that one? Yes, that's good. I got a to the 3rd, b to the -4th over a to the negative second, b to the 1/5, all to the negative 1/2. Now, let me tell you, there are several different ways you could start this. So what I'm going to fish from you is, what do you think? Well, what do you think we ought to do first? Anybody got an idea? Think about it. Give me something. Okay, I'm going to do that because Rachel said it first. She's going to do that power to a power first. Just so you know, that's not the way we did it first in first period. Okay, so if you thought something else, that doesn't mean you're wrong. There's more than one way to attack this, but what she said is a good way. So here we go. 3 times negative 1/2 on that A would be negative 3/2. Negative 4 times negative 1/2 on that B would be a positive 2, because the negative times the negative. Negative 1/2 times negative 2 would be a positive 1. And negative 1/2 times 1/5 would be negative 1/10. Okay, that got us a good start. Rachel did pretty good on that. Now you don't have a whole lot of options on what to do next. What would we do here? Whew, I didn't think of that. I could. And I think that'll work. Anybody got something else before? Because I think that way might be a smidge harder. But if not, I'm going to go with that. Zane said since that A on the top is a negative power, I can move it to the bottom, and that's mathematically right, so that'll work.
Simplify the A and B.
Okay, we could go ahead and since the A is being divided by an A, we could go ahead and subtract their exponents. That's what I would rather do first, Zane. It's going to end up being the same because my A is going to have to go to the bottom anyway. But on my A's right now, I got an understood 1 on the bottom, so I'm doing negative 3/2 minus 1, which is negative 5/2. So that's going to have to go down to the bottom in a second anyway, like Zane said. Then on my B's, I got 2 minus negative 1/10. So that's the same as 2 plus 1/10, which is 21/10. Now I'm caught up with what Zane was looking at. There's nothing else I can simplify A and B wise, but that A's got a negative power. So it's got to go on the bottom. So I've got B to the 21/10 over A to the 5/2. Can I show you what that would look like if we would have done it the way Zane did? It's cool. Y'all want to see that? If I had, we already got that 1A that's down there. That A to the first that's down there. So now we're putting the A to the negative 3/2 down there. So now down there you've got multiply. And what do you do with multiply? Add the exponents. So 3/2 plus 1 on that. 3/2 plus an understood 1 would still get you that 5/2 that we got, and it's already on the bottom, which is where ours went. So see, we still would have got the same answer. So that's pretty cool that Zane thought that. Anybody, we still never got to what first period did first. Anybody got a guess on another way you could have started that? It's not any better, just another option.
At the start, go ahead and divide.
You, let me talk to Aaron's first. Yes. Aaron said go ahead and divide before you distribute that exponent. Yes, you could have done that. Zane said go ahead and put the negative 1/10 up. So you're over here on this, Zane. Yeah, you could have done that, and that would have been the same as what you said with the A's. Yeah. What about and all y'all are right. Those are all good answers. This is cool that there's so many different ways to do this. We attacked that negative 1/2 power first period. We just went ahead and flipped the whole fraction and then made it to a positive 1/2 power. And we still got the same answer. So I think we've talked about right now 4 different ways to do that same problem, and we would all get the same answer. So that's kind of mind-blowing there, isn't it, Craig? Are you on this earth today? Just kind of sitting there in a zone.
I'm
Don't
not.
be getting pissy at me.
I'm
You know I'll smack you, right?
I know.
There we go. Just making sure. Don't worry, that's on camera. Can't even get you to smile. It's bothersome. Bothersome. Alright. Power rules, that's nothing new. That's pretty easy, schmeezy stuff. Any questions over any of that? Alright, how about if I give you a good old exit question with a twist? It's an easy twist, but it's kind of funny that people in first period got confused. Oh, don't write with a highlighter, that's never good. That says 36 to the 0.5 power. Your directions, EVALUA. Say to evaluate. I'm making the spot for your question right now. Right?
Evaluate.
Evaluate. That looks like evaluate.
Evaluate.
I don't know what it looks like. It's bad.
Looks like evaluate. Ow.
Alright, it's in mine, so give yours a second, refresh it if you need to.
Okay.
Okay.
This one, I got a problem.